In this example, using Lagrange's method, divide 24 into 3 parts such that the continued product of the first, square of the second, and cube of the third may be maximum. So now, in this example, using Lagrange's method, we have to divide 24 into 3 parts such that the continued product of first, square of the second, and cube of the third may be maximum. So let us suppose 24 is divided into 3 parts, x, y, and z. Then according to the given condition, x plus y plus z is equal to 24. Let us give it equation number 1. Now we use Lagrange's method of undetermined multiplier lambda to solve this question. So now what is the step number 1? In step number 1, we define u and phi. So what is u? U is nothing but the continued product of x, square of the second, and cube of the third. So the first part is x, second part is square of the y square, and third part is the cube of the z, so z cube. This is u, and phi is nothing but the x plus y plus z minus 24. This is considered as phi. So let us give it equation number 2 and equation number 3. So this is the step number 1. In step number 1, we have to first define what is u and what is phi. U is always with a, just look here in u, both the sides are variable, but in case of phi can be taken the equation, complete equation, which one side is variable, another side is constant. So here u is equal to xy square z cube and phi is equal to x plus y plus z minus 24. This is step number 1. The step number 2, we have to construct the function f is equal to u plus lambda phi. So let us consider f is equal to u plus lambda phi, where u is equal to x y square z cube plus lambda times of x plus y plus z minus 24. Now here, this lambda is called a Lagrange's undetermined multiplier, means we are only using the value of lambda, but no need to determine the value of lambda. So let us give it equation number 4. Now the step number 3 is form the three equations del f del x equal to 0, partial derivative of f with respect to y is 0, and partial derivative of f with respect to z equal to 0. So we have to just do the partial derivative of equation number 4 with respect to x, y, and z and equating to 0. So let us take the partial derivative of 4 with respect to x, y, and z respectively. We have del f del x. So derivative of uh, y square z cube is constant, derivative of x is 1. So we have y square z cube. And here derivative of x is 1 and the remaining will become 0. So plus lambda, which is equal to 0. And if we find out the value of lambda, it is this transpose to this side, and lambda equal to minus y square z cube. Let us give it equation number 5. Similarly, del f del y is equal to derivative of y square is 2y, so 2xy z cube, and here derivative of y is 1, so plus lambda equal to 0, which implies lambda equal to minus 2xyz whole cube. And similarly, del f del z is equal to 3xy. We have to differentiate partially with respect to z, so derivative of z cube is 3z square, 3xy square z square plus lambda equal to 0, which gives us lambda equal to minus 3xy square z square. Now, using all three equations, let us equating it from 5, 6, and 7. We have minus y square z cube equal to minus 2xy z cube is equal to minus 3xy square z cube. Now, dividing this whole equation by xy square z square minus, so this minus minus will cancel, this minus will cancel, this minus will cancel, y square, z cube, x, 1y will cancel, z cube will cancel, x will cancel, y square will cancel, and z square will cancel. So what is remaining in the first part? It is 1 upon x. In the second part, 2 upon y. In the third part, 3 upon z, which is equal to k. So if you want to find out the value of x is nothing but 1 upon k. Value of y is 2 upon k. Value of z is 3 upon k. Now putting all these values of x, y, z in the equation number 1. What is equation number 1? Equation number 1 is x plus y plus z equal to 24. So the value of x is 1 by k plus 2 by k plus 3 by k equal to 24. So it gives us 6 by k equal to 24, and hence k is equal to 1 by 4. Now we substitute the value of k in this equation number 8, then we are able to get the value of x, y, and z. Putting the above values of k in equation number 8, we have x equal to 1 upon 1 by 4, y equal to 2 upon 1 by 4, and z equal to 3 upon 1 by 4. So this 4 goes to numerator, it will become x equal to 4, y equal to 8, and z equal to 12. This is the desired partition of the of 24. Thank you.